So I got this comment, and thank you for the comment, by the way. And I agree. Let's make LLM easy to understand and easy to explain. So let's start from basics, like bare basics. Uh, I will try to make this so easy that anyone, like a 5-year-old kid, can explain LLM to his grandmother. Well, let's start from basics. So, what is LLM? LLM stands for large language model. So, the key part is large language and model. Just exclude the model part for now and large for now. The middle part, language. So, large language model, the primary goal of large language model is to understand languages and to communicate in a human natural form. So let's take an example of a book. I have a book. Let's say I want to make a LLM out of this book. Obviously, I will not put this book inside my system. I will convert this into a PDF file. After I convert this into a PDF file or any kind of format which you want, you load this PDF file into your code. Then what happens? It goes through the book and goes through every sentences, every word to look what is inside the book, right? Let's take an example. Let's say if I take the personal MBA as a sentence, I will consider this as an input text. Let's say I put the personal MBA as an input text. So the first key point is, for language model to work, you have to give an input text or input sentence. There's the first part. Then what happens? The input text then converts into token. So what are tokens? Tokens are nothing but if I make the personal and MBA separate, like a single word, a single character, or a single subword. Obviously, there is a one caveat here. A token can be a character, a word, or a subword. GPT uses subword, which is based on byte pair encoders or byte pair tokens. More on that in next video. But if we convert this sentence, the MBA into the personal MBA into tokens, then it would look like this, right? After we convert this into token, the process is called tokenization. So basically, we take an input text, we convert into token. The whole process is called tokenization. So to define tokenization as a definition, when we take an input text and convert into tokens, the process is known as tokenization. Token is also referred as vector. More on that in some another video. After that, we assign a value to a token, like a random value to a token. Let's say I give a number, roll number or roll call to our sentence for unique identification. Let's say I say the is number 54, MBA is number 12, and personal is number 6. So I assign a number to our token. So when I do that, that process is called giving a token ID, or the whole process of giving a token or token ID is known as encoding. So encoding, if I define encoding in a simpler word, when we give our token a token ID to like understand to make system understand what we are trying to give as an input, is known as encoding. Why we assign numbers? Believe me or not, but still our system uses binary operations to understand what we are working with. But the computation power of our system has been so powerful nowadays that we don't even think about it. Everything which you do on your system gets converted into binary number, then it goes through the CPU on different threads, and system understands what we are trying to do there. And why in binary? Because believe me or not, our system still runs on signal. 0 means off, 1 means on. So there is something which like it's very specific to electrical and electronics person. Like if you want to go into microprocessor, microchips, then this signaling part comes there. But for now, our system works on signals. Our system understand everything in a binary form. That's why we have to convert our sentence into numbers, so that we can provide some sort of computation to our system, so that they can understand what we are working with, right? After this, okay, we have encoded our sentence. So how we go, how we get like sentence back, not number. So from token ID to output text, when we convert that token ID to an output text, that is known as decoding. So what we are doing, we are taking a sentence, we are converting into tokens, then we are giving a random number to that token. This process is encoding. We are taking a token ID, then we are like doing some vector embedding. More on that in some another video. So after vector embedding, we are processing it, and then if you wanna have some sort of output, we are taking that token ID or vector ID. We are looking for associated word with them, and we are giving back the output text. That's decoding. Okay. So what is vocabulary? Like we got to understand about token, we got to understand about encoder, we got to understand about decoder. So what is vocabulary? So vocabulary is nothing but a dictionary of ascending sorted tokens. So what I want to say is, let's say we are considering the personal MBA as a input text. So the vocabulary would be like, so personal will come first because P comes first, then T or M. Am I right? A B C D E F G H I J K L M N. M will come, sorry, MBA will come first, then personal will come, QRST, then T will come. So we will make an ascending order sorted list of tokens or vectors without any repetition of a word. That is known as the vocabulary of an LLM. Then after that, what I can tell you is that there is some vector embedding. We will talk about that in some another video. And it's also easy if you get the gist of token IDs, if you got the gist of vocabulary, if you got the understanding of encoding and decoding, then it's fairly simple. But for this video, I will just conclude that the process of converting input text into token is tokenization. If we are giving our token an ID, a unique number to identify that token or vector, that is encoding. From that token ID, if we are converting that token ID back to our token, tracing back to our token, that is decoding. The sorted ascending order of tokens without any repetition is vocabulary, and the code for this will be in the next video with explanation. So I hope to see you guys in the next video, and yeah, let me know and comment, and have a great day, smile, and please subscribe, like and share.